Hello, and welcome to Thoughtful Climate, where each month we highlight experts, pioneers, and practitioners from a variety of existing and emerging climate tech sectors, as well as subject matter experts who can provide insights into the broader economic, social, and technological dynamics shaping the climate tech industry. My guests today are Christopher Sorensen, who is the founding CEO of Green Lab Denmark, and Kyle Gitchell, the Circular Economy Development Director at the Washington State Department of Commerce. Welcome, Christopher and Kyle, and thanks for joining me today.
Thank you.
So, we're going to be talking today about industrial symbiosis. But before I turn to Christopher and Kyle, I want to briefly set the table, as I do each time, for our conversation. You may have heard about symbiotic relationships in the natural environment, fungal species, for example, that grow on the roots of trees and provide critical nutrients to trees in exchange for carbohydrates, for example. And there are many more examples of symbiotic relationships in our natural environment across species and even across kingdoms. So, what can we learn from these natural symbiotic relationships that can help inform our approach to industrial efficiency, wastewater, and environmental impact reduction while creating new solutions and business opportunities in e-fuels manufacturing, for example, low embodied carbon product manufacturing, building, heating, and more. We've seen limited adoption of relatively simple bilateral forms of industrial symbiosis, where, for example, one facility's waste stream becomes another facility's feedstock, benefiting both, increasing efficiencies and profit, and reducing environmental and climate impacts. But increasingly, and particularly as our energy mix becomes more complex and technology cost curves come down, we are seeing opportunities for more multi-layered, complex, synergistic relationships between a variety of industrial market actors. And these new technological opportunities beg the question, do we need new economic development and planning frameworks to fully leverage synergistic sectors? So that's what we're going to be talking about today with Christopher and Kyle. So Christopher and Kyle, thanks again for joining me. I think this is going to be a really fun session, and I'm glad we'll be bringing two very different perspectives to this conversation. Christopher, I'd love to start with you, if I could. Please take a moment to just introduce yourself, and I'd love to hear your kind of elevator pitch on industrial symbiosis. I think you've been in this space for a while, and I think you've really honed it. And I think part of what I really like about it is that you have figured out a way to talk about industrial symbiosis that I think is really compelling from both an economic development perspective, but that also resonates with climate hawks as much as it does with investors. So, Christopher, I'd love to hear your perspective first.
Thanks, Galen. Thanks for the invitation, and happy to meet you all online. I'm originally from the New England area, born in Connecticut actually, and began with Accenture out of Manhattan as an international project leader, which launched me into my global career. Accenture actually sent me to Paris about my fourth or fifth year in, and I never came back essentially. So I've been working globally since then. I've gathered experience in innovation, technology, smart cities, renewable energy, and industry. And this has led me to create these resilient growth platforms by doing systemic solutions for these different stakeholders. More recently, MassCEC Group in Abu Dhabi, and then as founding CEO of Green Lab in Denmark. So right now I'm based in Denmark with my family. I work as independent advisor for the Danish Foreign Ministry and for the Director General of ISA, which is Global South Eco-Development, and for companies, regions, and boards which seek to create these symbiotic platforms. And the quick elevator pitch for these symbiotic models is that rather than focusing on the CO2, you can look for the model to lower energy costs, to reduce capex for the industrial participants, and to make a quicker operation startup for the installations. Because you're doing this as a cooperative effort. That is to say, you can create shared value by making a cooperative investment, which speeds up everybody's infrastructure efforts. And being the one point of contact for public and private entities means that you can actually get an umbrella permitting. You can get the land use all lined up on behalf of a large synergistic group of stakeholders. So there's a lot of advantages other than CO2, which one can play to in creating these platforms.
Mhm. Okay, great. Thanks, Christopher. That provides a good foundation for the beginning of our conversation. And Kyle, turning to you, first, I think it's really noteworthy and wonderful that Washington State has an industrial symbiosis program at all, and that you lead the department's circular economy work. So I'd love to hear a little bit more about yourself. And if you could, what's the origin story there for Washington State's investment in circular economy programming and market development?
Yeah, thank you. And to echo Christopher, thank you for having us on to have this chat. Um, so I would be remiss not to talk about some of the other folks that have really stood up the industrial symbiosis and circular economy work for the state. Because I actually came to this relatively newly. I started this role July of last year after working in other areas of policy around diversity, equity, and inclusion, housing and homelessness, and really having a lens on systems improvement from a government lens. That's my sort of passion is bureaucratic systems, which is a weird passion to have. I should probably examine that at some point.
Someone
Um,
has to care about that, Kyle. So
Someone has
I'm
to
glad.
care,
I'm
right?
glad you're focused on it. Yeah.
Yeah. So from this government systems approach, how are we making things work? Department of Commerce specifically, we do a lot of grant making. That's primarily Washington State's Department of Commerce is a primarily, not only, but primarily a pass-through entity for state projects. And so what the symbiosis work looks like from our point of view is back in 2021, through some hard work from folks like Center for Sustainable Infrastructure, CSI, iSustain, and Scan Design Foundation, many others, really pushing for, hey, you know, Denmark, Kallenborg, they've got this model around the symbiotic relationships between manufacturing facilities, between industries. How could we be doing that work here? Um, Now, that's not to say that work wasn't already happening to some degree here. We do have some examples of folks that either vertically integrated systems where they were reducing waste or sort of already had symbiotic relationships with each other without really knowing it or using that language. But
Mhm.
21 is when the grant program really kicked off, and that's when Department of Commerce started funding these community projects. Before that, and another part of my role is also as a part of our recycling market development center, which sort of lines up really nicely. And that's where the circular economy piece comes in, lines up nicely with the industrial symbiosis work. And that's a partnership between commerce and ecology that started in 2019. So you come out to Washington, people do care about, the climate impacts, but we also have to have conversations really rooted in matching climate impact with economic growth when we're talking about these things. And that's why Commerce has this program. That's why our Office of Economic Development, where I'm seated within Commerce, has this program so that we can have those conversations really concentratedly. Um, the other piece of this that's been successful in bolstering the funding behind the grant program has been the engagement with the legislature. Our state legislators, several dozen, have been on these foreign study tours to go to places like Denmark to see the infrastructure, to see what it looks like to do symbiosis at scale. And that's bipartisan as well. I mean, we're talking both Republican and Democrat representatives and senators in our House and Senate at the state level that are participating in this and supporting this. So a lot of work going into making it happen, but glad to be here.
No, that's wonderful, Kyle. And I appreciate what you said about that this seems to be the kind of the evolution of perhaps the next natural step for us to take with regard to industrial efficiency. There's been a lot of focus, and I think a healthy embrace of industrial decarbonization and embracing clean energy, not simply for the sake of or in service of climate objectives, but to reduce energy costs and improve resilience. And I feel like the kind of next evolution, natural evolution in this space is to take it a step further and begin to think about the symbiotic relationships between industrial players. And I think that's what I find so intriguing about this space. So I do want to provide for both of you. I do want to provide our listeners with some concrete examples. My sense of this space, and this is very similar to, I think, how I've been an observer of the microgrid sector for a long time. And as the saying goes, if you've seen one microgrid, you've seen one microgrid. And similarly, I'm wondering if you've seen one industrial symbiosis park, you've seen one industrial symbiosis park. In other words, that there are probably many different permutations of what industrial symbiosis might look like in many different scales. But I would like to provide some concrete examples for listeners so they really understand what we're talking about here. And that can involve, for example, the exchange of materials, including waste. It could be the exchange of thermal energy or water or some combination of all three. But there do seem to be some symbiotic relationships in the industrial space that perhaps are a little bit more repeatable, more common, including the exchange of thermal energy, for example, where one facility's waste heat is used productively by one or more other facilities, waste to energy and waste to fuel solution examples, novel uses of treated wastewater, carbon capture. So maybe we could start with heat first, making use of waste heat. There's no doubt that higher natural gas costs in Europe have encouraged the creative use of waste heat there. I was shocked to learn recently, actually during a visit from a delegation from Denmark, that waste heat in the EU is estimated at approximately 2,800 terawatt hours per year, which to put into perspective is roughly equivalent to the EU's total demand for space and hot water heating in the residential and service sectors. So an enormous resource that's going untapped there. So I'm wondering if you could both quickly provide an example. Maybe we'll start with you, Christopher, of industrial symbiosis that specifically involves the productive use of waste heat.
Yes, of course, and I think Denmark is probably the leader in Europe in this domain. However, the prevalent structure has been combined heat and power and industrial waste heat to residential users. So we've been very good at creating this district heating systems. And I can mention in Abu Dhabi, they did district cooling systems. So both thermally based and very effective. However, most of us are familiar with the Lawrence Livermore Lab analysis that shows 60% plus of heat going to waste in industrial processes. And this is where we took a conscious decision in Denmark to do something about that. As Galen mentioned Kalundborg, which is an industrial area around a harbor where the neighbors organically over decades started, connecting themselves and making more cost-efficient use of their heat and the waste heat. While Green Lab, which is the first operating example of a built-for-purpose heat and resource symbiosis net. In fact, we trademarked symbiosis net as part of our recognition. Coupling industrial partners, so B2B, directly connected, and at high temperatures and scale, and driven by renewable energy. So we're directly connected to renewable energy park to ensure low CO2 footprint as well as the heat exchange. So this conscious infrastructure design and the proportional storage and conversion elements enabled heat to be reapplied. And specifically in the Green Lab example, we had protein extraction and dryers, we had biogas plant with methane upgrades, pyrolysis plants, green hydrogen electrolyzers, and residential district heating, all as part of the symbiosis. And we could see temperatures cascading. So you get one source of heat cascading from 300 to 220 to 180, 130, 80, and 50 degrees C. And if you have, one high temperature heat source as waste heat, you can reuse that, at these different levels of input and output streams, as long as you create the infrastructure to make that work. And economically, that works best if the distances are relatively short, because the thermal pipes to exchange are, as we all know, quite expensive. So we designed this cluster to make the best use of that unified cascade. And in fact, this year, Green Lab will complete a renewables-powered thermal storage, which can provide up to 1200 degrees C to the park and attract new industrial users who need that higher temperature as well. So not just waste heat at maybe 60 or 80 degrees, but actually high temperature heat, which can become part of the top side of the cascade effect, and then
Mhm.
provide input and output streams to various different processes. That just requires, of course, a conscious design. But once you do the
Sure.
conscious design, you can also create attractive profiles which attract new industries, and you can then enhance iteratively the infrastructure and the exchange process.
Well, in a more sophisticated or granular sense of what the specific heat needs are, as you note, right? So there's
Exactly.
you've got the higher temperature waste heat, which may be useful for some processes, and the low temp heat, which could be very useful for, say, for example, space heating in the residential sector.
Yeah.
I think
Or
I've seen
even
that.
Galen, one of the things we found interesting was there's some preheating in some of these industries as
Mm.
well, because they need to
Hmm.
maintain temperatures. When they have input streams coming in, like biomaterials, they can't just toss them in and figure it's going to work out. They need to manage the gradients. So even 50 and 80 degree heat could be used in preheating processes so that you maintain balances, for example, in biogas plants where the bacteria has to thrive at certain temperature thresholds. So there's a lot of nuances which are underserved in many industries, in fact.
That's great. Thank you, Christopher. And how about you, Kyle? Do you want to, we can pass on this too, but do you want to speak to the kind of productive use of waste heat in Washington State?
Yeah,
Are you seeing examples of that?
yeah, I could give a couple of specific examples. I'm not going to be as elegant in this as Christopher. I think he's got quite a bit of knowledge, and that direct experience with Green Lab is useful. From our area, though, we have, for example, an Amazon facility in Seattle that is centered between multiple other buildings that have data centers, different sorts of types of waste heat. And I know data centers are a part of the conversations in economic development right now. So it's really timely to note that Amazon has taken the waste heat off of a data center where actually our Department of Commerce's Seattle office is located, and is pulling that waste heat into their facility to use as part of their heating infrastructure. And so if you've got this, corporate building that's sitting there that's not then having to generate their own heat. They're able to, because of pulling off multiple buildings waste heat, they're able to many times of the year just not even run their own heat generating systems. It's just using that waste heat. Another example, which we had touched on a little bit before the call started, is the project that we've got going on in Longview, where there is a set of companies that are very closely co-located with each other. There's a pulp and paper mill, there's a packaging company, there's a lumber mill, and that pulp and paper mill and packaging company, they sell steam heat. One sells steam to the other. One that reduces the amount of generation of new steam that happens in the area, which is obviously lowers the energy usage for the facility. But it's a cost savings for both as well, because then they're not having to pay for as much generation from the one facility, and the other facility is able to have another revenue stream by selling off steam. And so it's really interesting to see like something that would have just gone up into the atmosphere, and then both facilities having to generate their own heat. You can then take that waste and sell it and actually create a new revenue stream for a business off of something that you would have just otherwise been dispersing.
Yeah, absolutely. And I think that this actually came up conceptually. I mean, at least one of the projects has been pulled back here in Massachusetts. But I had a conversation with a colleague of mine, also in the economic development space, and we were talking about a data center that was planned for a community in Massachusetts. And a food processing facility that was also planned for that same community. And of course, the immediate thought there was food processing is very thermally intensive. You have to produce a lot of hot water, and data centers produce a lot of waste heat. And so I think this requires, it's a new way of thinking for economic development practitioners to kind of apply this energy knowledge to help inform economic development decisions resource allocation, incentives, and technical assistance in a very concrete way.
Yeah,
So thank
and
you for those examples.
to sort of highlight the point that you made earlier, Galen, you see one industrial symbiosis park and you've seen one industrial symbiosis park. It's, it sounds really similar. There's a lot of steam exchange, there's a lot of cogen, there's a lot of anaerobic digestion. But also to the point that Christopher was making, there's subtle differences in the needs, the outputs, the exchanges. And from a government entity perspective, that's part of what makes it challenging and also fun to try to figure out, what are the individual needs. There's not a specific plug and play that you can just do like, oh yeah, just sell Steam and you'll be fine.
Right, right. So why don't we, thank you. That's very helpful. That's a good concrete example for folks. So making productive use of waste heat. Let's, if we could pivot to waste to energy or waste to fuels. So there are innovative companies here in Massachusetts, and I know around the country and indeed around the globe that are developing novel approaches to process mix municipal solid waste, MSW, for example, via a variety of very high temp processes, but importantly, those are not incineration, so pyrolysis and others. Um, and also, those same technologies can be used to process sludge, so septic system waste, and through those processes, you can blend those resources with CO2 to produce biofuels, to produce methanol, other useful byproducts. In some cases, you can also destroy PFAS in the process, which is a goal that is broadly shared. Um, so I'm wondering if either of you could speak to examples here of symbiotic industrial relationships that are leveraging waste materials um, and MSW in some cases, municipal solid waste, to produce e-fuels or other useful byproducts. Christopher, do you want to lead us off? Oh, and you're on mute, Christopher. Sorry.
Classic conversation with myself. It went really well, by the way. So there's one consideration is PFAS and other wastewater products, which often are difficult to process and difficult to find a home. And we found some nice solutions where you could treat the water just enough, for example, getting rid of heavy metals, but then PFOS and PFAS, they could be applied to electrolysis, which splits them. So it's taking care of that problem, which is really difficult. We've got a lot of research in Denmark where we're quite eccentric about our groundwater. We want it 110% pure. Otherwise, it just doesn't work. So we work extensively on that. And electrolysis is one of the best applications to get rid of PFOS and PFAS. And you can use wastewater or industrial water sources to do that. So redirecting that from the current treatments for pesticides and likes over to getting it just enough, not to potable water, but to electrolysis level, which is deionized and no heavy metals, but otherwise quite tolerant for these types of things. The other side of it, as you mentioned, is pyrolysis, and I've seen pretty much the spectrum of pyrolysis. One of those I really like is agricultural waste to pyrolysis, which provides biochar. And if you're very, very good at the pyrolysis, you can get organic level biochar that's non-contaminant with tars or other things, and that can go direct to the fields again and improve soil quality. So that's a great CCU process. Other pyrolysis I've seen is on plastic waste. In fact, we had a startup at Green Lab, which became acquired by Viridor, a global waste company, after 3 years, and has been globalized already after 5 years. So this is an economically viable reuse and upcycling of waste plastics. And then finally, landfill and organic waste in particular. I'm aware of CORE in the USA, KORE. I believe they're out of Massachusetts, in fact, or New York State, but very, very close to where you are, and starting to globalize their landfill organic waste processes to energy and to fuels. There's also microwave systems, which we've trialed in Denmark, again to organic waste, direct to fuels, and of course steam reforming and biogas. And what
Hmm.
I'm seeing more and more is the biogas process turning into multi-value streams. So you have the CO2 capture for bio CO2, which can be used for fuels. You have the waste streams, which are fiber, a lot of fiber involved, which can go to pyrolysis for agricultural and biochar. And then you have direct steam reforming for turning biogas into fuels, which are bio-based fuels, which means circular CO2. And all of these are in what you might say growth and commercialization phase. So it's a question of finding the right sites with the right needs and the right clusters so that you make them more and more viable and then can scale them up appropriately.
Yeah, thank you, Christopher. And I do want to, I don't want to kind of underestimate the challenges there. I've had a number of, I think, fascinating conversations recently with really very thoughtful colleagues in state government here in Massachusetts about uh, supporting and advancing advanced waste to energy approaches. And there are a wide variety of technology solutions, but you're absolutely right that the siting, can be very challenging, and then the financing for those projects, aggregating enough waste. And in this case, in the context of industrial symbiosis, thinking about whether it might be possible to locate facilities near kind of an anchor um, feedstock producer, if you will. So a number of different challenges. But given that the tipping fees are so high for waste removal in this state, it's certainly a good time to be looking at new solutions.
I think you
And
touched
then
on a good
Kyle.
point, Galen, with the input streams. And often that's
Mhm.
really the key factor. So and co-location. So for example, biogas, uh, continuous process provides these residual streams, which are fiber heavy. The farmers don't want the fiber, they want the nutrients. So if you sort out the fibers and the biogas is already clustered around the input streams, then you have a direct relation between the biogas and the pyrolysis, which becomes very positive products like biochar and fuels. But input streams and the competition for input streams. So where you have tipping fees, suddenly the waste
Mhm.
becomes more and more valuable, right? So
Right.
everybody starts competing, which means you get a fragmented market. And in this case, public-private partnerships and the community working to consolidate these input streams to processes becomes an important element of putting these clusters together. So there's some nuance there. You can't just show up as a commercial actor and hope, to make sure you can consolidate these input streams and make it viable. Often it requires a good consortium, including the public and private entities, to make sure that this becomes viable by consolidating those input and output streams.
Yeah, agreed. And specifically, I've heard that it's very helpful, for example, if you have, offtake agreements that may be anchored by the public sector to provide, for example, e-fuels for sanitation trucks.
Yeah.
Um, just one example. And then Kyle, to you, either if you feel comfortable speaking to this or just toward examples of kind of symbiotic materials exchange between industrial facilities in Washington State, whichever
Yeah.
approach you'd like to take.
Yeah, no, I've got a few examples. And actually, I think we could send it out after this, but the Washington State's Industrial Symbiosis Program webpage has a litany of examples of things that we have funded.
Oh,
And
great.
a lot of them go towards the renewable natural gas from anaerobic digestion, the materials exchanges. There's a bunch of things there. One I wanted to highlight specifically at this point, though, Pasco, city of Pasco over in eastern Washington here, they have been developing uh, a wastewater reuse facility. So what they're doing is they're pulling wastewater from multiple food processing plants. The wastewater is very high in nitrogen content coming off of that food processing process. And what they have done is integrated algae denitrification into the system. And so there's a few things that are beneficial there. One, they can pull this wastewater off of these plants, use the algae to denitrify, reduce the nitrogen content in it, and then use that water for agricultural usage. So lots of
Mm.
agricultural land, lots of crop use there. But because of the slight nitrogen content that's still in the water, it reduces the fertilizer need on the land. In addition to that, the algae is then being used as a fertilizer source itself, which is then another product that's created from that process. And they're adding on renewable natural gas to this as well. So for those things that aren't pulled out by the algae, aren't pulled out in the treatment process, they're able to use the anaerobic digestion process to then pull natural gas off of it. So you've got multiple food processing plants that are pouring into this one wastewater reuse facility that is then getting co-products and multiple uses, revenue streams off of these. That are having environmental impacts, that's having revenue stream generating benefits. And it's really cool to see this sort of multi-purpose approach just to something like a wastewater treatment facility. There's a lot to be captured there. And these things are happening at both a very large and a very small scale, uh, not just in, that's a huge municipal project. To speak to something on the other end of the scale, we have a company that is pulling shellfish waste out of the waste stream prior to even entering the wastewater treatment facilities, right? So you've got fisheries around Washington State that are able to partner with them, sell off the shellfish waste, and that's being turned then into a biopolymer. Um, they are chitosan is the name of the
Mm.
material, but they're turning it into a biopolymer and using that for other industrial processes. And so it's cool to see sort of at both ends of the scale. You have companies that are privately being able to take advantage of some of the symbiotic relationships and some of the like recycling innovation that's happening within those materials exchanges, and then also at the large public sector scale, public works scale, you have co-generation and this other revenue generating benefit coming off of this work.
That's great. And I think I think this is a good opportunity to, I thought we might have time to get into carbon capture and storage or sequestration, and we may near the end, but I think I'd like to pivot now to okay, this all sounds great. How do we encourage this kind of activity? I think that a lot of people would be very curious about that. So those are, I think, the two broad topics I'd like to cover in our time remaining: the kind of regulatory or economic development programming structures that encourage and support this kind of development, then I also want to talk about how these deals are papered. You know, what type of contractual relationships exist between industrial symbiotic partners. So, um, Kyle, let's start with you because that sounds like a fascinating example. Like, how did that relationship start, right,
Mm.
between the shellfish waste producer, if you will, that waste stream, and the biopolymer manufacturer? I mean, did they meet at a cocktail party? Like, how do these things happen? And how are you in your role kind of facilitating this matchmaking and this relationship building? Some of it may happen right through
Yeah.
natural networks and market forces, but this is a big part of your kind of charge, right, in leading circular economy activities, that you're trying to facilitate and encourage these types of strategic partnerships.
Yeah, and I did say at the top of the hour that I was into bureaucratic systems. So this is the this is my time to shine. Really, what a lot of this looks like, honestly, in that specific example, this is something that the folks over at the Tidal Vision is the company there that they've developed the technology, they developed the all of the research, the engineering, all of these things. Where the state is able to step in and where our role within the circular economy. As a state entity are able to step in is catalyzing in a couple of different ways. So there's a ton of innovation, a ton of great thinking, folks that are able to say, hey, I see a problem and I've got a solution for it. However, to a point that was made earlier, the financing can be a barrier.
Mhm.
Knowing about each other, knowing about where to site, who to partner with can be a barrier, and some of the permitting can be a barrier. An example of permitting issues, we had a project that we funded through our grant program that the county that they were siting in didn't really know what to do with it's like, do we need the air quality permit to look like this,
Hmm.
or do we need it to look like that? Which, put some delays on. They ended up successfully implementing their project, but some of these things take additional time because it is new. And so part of
Yeah.
our role at the state level is in the connecting, the educating, and the funding of these projects. Um, I think that the grant program specifically that we have, so we've had in last grant cycle 51 applicants applied, so that was a huge amount of interest. Only had enough funding to fund 11 of those projects, and right now we're seeing similar. We're working through a current grant cycle right now, and we're seeing similar levels of interest. And that's great to see. That means a lot of people around the state have all these projects that are ready to go, but
Mm.
the financing is an issue. The funding is an issue to really get them over that hump into commercialization or actually doing the activity. And so that's a part of it. The other part, when it comes to sort of that matchmaking or learning, like where do I site, who do I partner with, that comes into honestly having conversations like these where I'm able to come out and say, hey, I'm me. Who are you? What are you up to? Hey, now we know there's another company that's doing this that's really interested in this stuff. Let's connect. Let's talk. A lot of talking, a lot of connecting, and that frankly
Mhm.
goes a long way. It's the relationship development, the relationship building that's important. And in addition to that, we've got a program that we're just starting up this year for technical assistance, where we're able to contract. We're working on contracting with one or more entities to get out there and do some more deliberate feasibility design, education, some of the community design and engagement work that there's two of us in the circular economy team for a whole state of people. And so having that contract will be really helpful in getting some more focus in on specific community projects that are interested in doing this, that maybe funding isn't always the issue. Maybe it is an education thing. Maybe it is a networking and connections thing that they need, and we'll be able to support that more readily.
So I'm hearing a little, so thank you for that. So I'm hearing kind of a mix of technical assistance. There's some straight up like biz dev, business development, connecting folks. But like tactically, are you your funding solicitations, are you supporting kind of feasibility studies? Are you supporting actual projects like steel in the ground, or how are you actually deploying your funding?
It is a mix of those things.
Okay.
And where the trick is how we evaluate and prioritize different types of projects. So we've got an evaluation process that uh, helps us to pull out sort of those ready to go projects, those ones that are like, hey, I just need like this amount of money and we'll be implemented and we'll be commercialized. That's not to say that we do fund feasibility, we do fund engineering, design. Um, and folks really like to see the shovels going in the ground, something's getting built,
Mhm.
particularly when there is a clear both climate impact and jobs impact for the area. It's really great to see when there are jobs that are being generated from this work, and I think it helps to highlight the ongoing success of the program and make sure that that funding continues to happen for folks to be able to get out there and put these projects into motion.
Mhm.
Jumping back to the Tidal Visions example with the chitosan going into biopolymer, there was one fishery in the state that wasn't going to do their shrimp season because they couldn't afford it. And because of the funding that we provided to Tidal Vision, they were able to take up this partnership with them, buy the shrimp waste, and turn that into their chitosan project process. But what that allowed that fishery to do is continue that season. They were able to fish for that season, which is,
Oh,
you know, several jobs in a rural area that would have been greatly impacted by the loss of those employees, that employment. So, um,
that's great. And
it's
then
it's
diverting that
revenue
waste,
generating.
right, from
Yeah, it's
landfill or yeah.
exactly. We diverted the waste and created jobs all at the same time.
Mhm. Great. And then Christopher, how about you? I remember we first sat down and talked about Green Lab. I was kind of wondering how, how did that all come together? And, was there kind of a master developer type approach? And then I'm also reflecting on the conversations we had about, what that might, what an exploration like that might look like in Massachusetts. And I think we had begun to have some very rich conversations around gathering together experts who have a sense of the kind of waste streams that are available in different regions and the different assets of different regions around the Commonwealth of Massachusetts and how that might inform a more kind of detailed exploration or audit of industrial symbiotic opportunities. Um, yeah, I'd love to hear kind of how Green Lab came together and whether or not that same approach might be useful for us here in the Commonwealth. Well, and sorry, Christopher, you're on mute.
Just trying to give you guys the space so I don't jump in too much. So, I mean, I've worked on this, initiating these platforms from top down via sovereign wealth funds and billions of dollars as a strategic effort in Abu Dhabi, and from community based, which was Green Lab. They were losing citizens, losing population, and just needed to renew their region to attract new citizens to the area. So they had a burning platform basically, and they said, "What do we do?" So they started a community effort, and then we started mapping and building up what one could achieve there, based on some of the experience which we did in Abu Dhabi, where we had the budgets to trial a lot of things and make it work in the end, so to speak. So both approaches are valid, but if you just want the quick win, the basic attractive proposal to get some momentum, then I would suggest, whether it's a rural area or a port or a dense industrial area, looking for those opportunities where you can develop added value streams, which can convert typically cost centers to profit centers. So often you have to get rid of something, and that costs you money. And it's not your core competency, it's not your product output. It's just what happens when you produce something. What are the other, upcycling or repurposing of that stream, which could become an added value to your business? Biogas is probably one of the great examples, because they just want to produce the gas, right? When they separate the CO2 from biogas, it just goes up in the air, and that's, plant-based gas, so it comes back to the plants. It's all good. But if you can convert that CO2, which goes up in the air, to a synthesis product for green fuels, suddenly now you've converted that just cost of upgrading into a potential revenue stream, because you can now sell the CO2 as biogenic CO2. Well, that's a good for the economic value of the plant you've already invested in. On the other side, the degas material has the fibers, which you have to get rid of. And in Denmark, that costs money. And perhaps the tipping fees in Massachusetts would be the same. And you could just send that over to the pyrolysis process, create the organic biochar, and again, synthesize fuels, which in turn could create heat input for your biogas plant to upgrade. So it's just simply, in the beginning, looking at waste streams converting to profit opportunities. So multiple value stream models gives the industrial centric, the egocentric, what's in it for me, begins to say, hey, there's something in it for you here. Let's just look at a couple of things going on and how we can convert that. So those are quick wins just to get the onboarding, so to speak. I've heard about Boston Harbor having some sectors which need to be regenerated for continued longevity of the throughputs, or some industrial areas up near Salem where you're doing the offshoring of wind parks, or the Western region where there's some underserved areas and you want to attract new competencies and new businesses. They all have these potential profit streams, which you can then coalesce into the anchor points of a new symbiosis. And then you're developing, okay, what are the gaps? But most importantly, the stakeholder engagement is the most important key. So does the community want to do something, or are they against doing anything? If they're against doing anything, then just don't go there. Go to the next community. Right. Same with the industrial partners. Do they see strategic value in looking towards extending their assets or finding repurposing their heavy investments, gaining new revenue streams, great. Let's get to work. Let's roll up our sleeves. And then the question is about how do you create the infrastructure which will serve those purposes, and preferably attract then new industries to help the rejuvenation process, help bring in new competencies, and create new economic value, both for the public and the private sectors. And designing that incentive model and then the follow-on business operating model will emerge as those stakeholders become more and more involved, become more informed about the potential value streams can be, and then how the symbiosis will actually create more resilience for their process and lower costs. And this is interesting. You'll notice I haven't mentioned CO2 yet. The challenge with CO2, it's an intangible, invisible, you can't see it, smell it, or use it for much of anything. We exhale it, right? So what's that going to do with anything? And you can have your climate views, whether plus or minus. But if you put that on the shelf, you'll find that designing these systemic solutions and creating more value streams will inherently reduce the CO2 footprint because it will be repurposed as part of that process. So you don't need to make that the top line issue. The top line issue could be value creation and more resilience and a future growth model which has a longevity with built-in reduction of costs and increase of economic value.
Yeah, that's very, very helpful. It's very important to underscore that the sheer kind of economic development and economic efficiency benefits of this approach. And you're absolutely right that the carbon benefits can be kind of a byproduct almost
Exactly.
of this approach. But you're
Yes.
reducing waste, increasing efficiency, increasing profitability, and I think particularly in this environment right now, that's what we should be emphasizing and leaning into.
I
Um,
could just note for you, Galen, just as a US context, the collaboration we have the USDA and the Danish Foreign Ministry, which we signed about a year and a half ago, that looks to generate economic value for communities where, for example, invasive species are taking over the natural ecosystems. And the USDA have been struggling with, what do we just rip these pinyon junipers up, also up in Cal's domain, the Northwest and down through Nevada. This stuff is just taking over everything. Well, then you'd have a bunch of, wood chips and holes in the ground. So there must be a more elegant way to solve the problem. And being able to say, okay, let's take this product, the pinyon juniper, excavate it, reestablish the natural balance, but then create economic value out of that input stream and involve the community in building these industries and new fuels and new synthesis processes and pyrolysis processes. These are new competencies, new processes which generate value for the community, which means new schools, people moving in, outlying areas become more populated with higher level competencies. And then you tie those hubs together. So they start increasing the regional trade and enhancing each other's symbiosis. And then in the end, you have, delivering to the coastal regions or increasing trade to the Asia Pacific. They create rings in the water as you build out from this core challenges and turn them into economic opportunity.
Yeah. And if just to highlight something in there, the economic viability part of this is a really powerful conversational point for a lot of
Mm.
people. I grew up in a rural community, very heavily focused on logging in its economy. And growing up, that the conversations about environmental protections, these types of things, talking about spotted owls and, oh, I can't log the forest anymore because of the spotted owl. It was difficult to have those kinds of conversations around environmental protection and climate change. But when we're talking about, again, the revenue generating, we're talking about jobs creation, we're talking about industry creation. I'm having just as much conversations with folks that would have if I was approaching this from a protect the spotted owl sort of conversation approach. I'm having just as much conversations with those folks as I am with anybody from, more traditional urban areas that care about this stuff, traditionally more around the climate aspects. But they're just as excited. And it's not that they don't care about the climate benefits of things. It's that jobs are very important in the rural communities. Industry is very important. Rural America needs the help, needs the additional economic development, and this is an opportunity to do that.
It does occur to me that this isn't maybe so much a question, but just an observation that in thinking about the waste streams, I mean, there's some amount of waste reporting that strongly suspect that industrial actors, it's a regulatory burden, right? There's a certain amount of waste reporting in our state, and I'm sure in many, many other states. But it does, if you flip that and think about it in another way, it becomes kind of a waste audit in a way that allows you to begin to identify opportunities. We cannot begin to kind of contemplate what the opportunities might be with regard to industrial symbiosis without a better understanding of the various waste streams in any given region. And it just makes me wonder whether or not kind of conducting those types of waste audits, which I think are oftentimes done at the kind of institutional level in order to address costs or reduce waste, might also become useful assets themselves. Um, I did want to talk about we don't have an enormous amount of time left, but I did want to talk about, Christopher, how you paper these deals, because again, I remember being kind of fascinated by our first conversation about what the contracts look like between industrial symbiosis players and particularly the kind of the contracts that kind of anchor the relationships or anchored them at Green Lab. So yeah, I would love to hear about that side of the story. Obviously, the technology component is critical and fascinating, but let's be honest, like unless we can kind of paper these in a way that's kind of respected by all parties, these projects will never get off the ground. So we'd love to hear about that
Yeah,
piece of this
it's
story.
an interesting evolution. We started with, bilaterals, which became trilaterals, which become more and more complex. And in the end, we determined, well, this is not going to pan out. As each new element you turn in becomes an exponential increase. And we know how adding one factor creates, an exponential increase in complexity. So we found that, in fact, what we needed to do in that case was to take on the design and investment in the infrastructure, basically designed to suit, but also with a dynamic and agile approach, an iterative dynamic approach to the design. So not quite design as you go, but we could phase it appropriately to the arrival and commissioning of the various industrial partners. So the anchor partners, which were three or four of those, mainly agricultural-based extractions, biogas pyrolysis, and the like. And then the electrolysis came in, and we could design the infrastructure for that. We built our own wind and solar park, and we said, okay, we'll provide the energy. You plug and play. That means we're already saving you money on your energy infrastructure. So there's already a capex incentive. However, you are committed to a 20-year connection to that infrastructure, so we can depreciate appropriately and provide this energy as a service for your processes on that basis. And then we begin to get the back-to-back installation going. And then as we became more nuanced on the heat exchanges, on the material exchanges, serving hydrogen to abate natural gas, or even using our pyrolysis to create heat to abate natural gas in the biogas plant, um, we said, look, we will take on the investment if these two, three, four parties would agree to be the off-takers. So we invest a couple $1 million in the thermal exchange infrastructure based on committed service contracts per commissioning. So in the end, we became what we called facilities as a service.
Mm.
And you can design this at scale. We are at about 100 megawatts of scale, which is reasonable, and it works. And you can actually make an operating profit once you complete this. And it is today making an operating profit after just 5 years from a grass field to installation. But if you do it at a larger scale, it's even more economically viable. So once you get up to these 500, 800 megawatts or gigawatts, the economies of scale and infrastructure become much better, which is why we have utilities, right, to
Mhm.
consolidate sources and uses of energy. So at scale, these platforms can actually provide lower cost of energy, reduce the CO2 footprint, and create, for example, renewable energy parks are the quickest way to provide new energy instead of waiting for a nuclear plant or a coal-fired power plant.
Mhm.
So combining the two means that you can create lower cost of energy and quicker service uh, tailored to the needs and to the projected needs and to the attraction profiles which the community and stakeholders are seeking as an outcome. So essentially, this model, facilities as a service, is the basic context for doing these types of engagements. The other ones I've done around the country are more multilateral. So you can have for example, in the San Joaquin Valley, you're looking at wineries, food processing, certain industries, and they can, because they know each other relatively well, a lot of them growing up family-owned businesses, we can get people around the table and say, okay, which input and output streams could we recombine here to create new
Mm.
value streams for everyone involved, in particular during market downturns or where you're looking for higher margins than just delivering tomato paste or Gallo wines in big paper containers. Uh, and that, working in these iterative processes with the industrial people who are looking to create new value can be very, very productive. So these are the two models I've best success with. Of course, the
Okay.
public side and the community side is a critical factor here.
Thank you, Christopher. So I do want to get to at least one question I see in the Q&A, and then if we have time, Kyle, kind of maybe a short question for you as well. But there is a good question here, and this I've also wondered the same. I love this concept. I think there's a lot of promise. I would say the one kind of concern I would have with this, right? And you can think about this in terms of any of the industrial, kind of eco-industrial or industrial symbiosis park models we've discussed, is that at the end of the day, these are private entities. Markets change, market conditions change. And you've built some infrastructure, perhaps with some shared, in some cases, literally infrastructure pipes that are exchanging, maybe water or therms. And then one of those companies moves on or folds. So how do you is there a way to kind of plan that? How do you plan resilience into these industrial symbiosis parks? And is it just fair to say that, there may be changes along the way and you have to kind of design some degree of flexibility into your into your park design, if you will?
Yeah. A couple brief points on that, and then I think Christopher probably has a really great answer for this. But I would also be thinking about the resilience that some of these processes add as well. So there is always going to be variability. There's always going to be volatility in some of these supply chains and demands and things like that. But when you are making your supply chain more localized, more domestic, you're also increasing the resilience of that supply chain. And so while you do have some of the variability, you also have some reductions in variability because of the domestication of the supply chain, the shortening
Mm,
of that. And that's where, to Krister's first point around the Green Lab model, or where you see this entity that is actively managing these partnerships, that's where that really comes in handy, is you have somebody actively looking for the continued growth and the sustainment of that industrial symbiotic relationship.
And I can just supplement that regionalization is one of the keys. And then that region becomes a trade partner for other regions, whether overseas or internally. And I call this piece, the regionalization, the cooperative advantage. And that outplays competitive advantage, which I think is becoming obsolete in our circular economy. I'm trying to work on a thesis for this so we can publish it and everyone can just read the way to this. But the manage of risk of these up and down cycles in industry, number one, you can design for that because all these industries know what their cycles are, and you can look at the prognosis of how those are and work with countercyclical. processes, energy and output streams, up and down cycles. So you can design for countercyclical symbiosis. And then in the end, the diversity of these clusters or these integrated systems becomes your resilience. And if you design your business model as a cooperative one in which everyone participates in the shared outcome, so we all have an incentive in the group outcome rather than our individual outcome. Of course, you have to run your business like you always did, but there's something more to gain by sharing resources, lowering costs, and having mutual incentives for the group profits, the group results, the community outcome as a holistic approach to creating these interdependencies. And that means everybody's doing the best for the group outcome. And that's not always, an easy journey to conclude, but it is very, very resilient and it does work.
Well, that I think is a wonderful way to end the conversation on a positive and hopeful note. I wish we had more time, but we're out of time, and I want to respect your time and the time of our listeners. But I want to thank you, Christopher and Kyle. It's been a really wonderful dialogue. I've learned a lot. I think that my wonderful colleague Shayla, who helps me produce this series, Thoughtful Climate, has dropped a link to sign up for the series in the chat. And just really want to appreciate you both and your time and your contributions. And I think it's been a really wonderful dialogue. Thanks so much. And thanks for everyone for joining today.
Yeah, thank
Thanks
you.
for the conversation.
Wonderful. Take care, all.